Okay, this is a lot of things we are designing tweet counts per frequency. To explain you, let me first go to the the definition here. So you have to build a class tweet counts. It has two APIs. One is tweet name and another is time. Time could be, I think it's minute, hour, and day. Minute, hour, or day. So that could be the time there. It's int. So we'll go to the details soon, but just you understand that for any tweet we have to store the time when this tweet came at, and then you will be asked like this thing frequency on which granularity, is it minute or hour or day. Tweet name, the same thing which we were storing here in the first case, and start time and end time. So you have to return all the tweets uh, between that time for that particular key and that granularity. So we'll go through the example and it will make more sense. So something like this. You will record tweet 3 at time 0, tweet 3 at time 60, tweet 3 at time 10. And all these are basically currently in seconds. So this means at 0th second, there was a tweet 3. Again at 60th second, there was a tweet 3. And at 10th second, there was another tweet 3. Now, if somebody asks me, like, okay, give me the frequency where the granularity is minute and we are looking for tweet 3 from 0 to 59, I should return 2 because we had tweet at 0 and 10th. 60th is not in that range, so we'll ignore that.
I have a question. You mentioned that it was 0 second, 60 second, and 10 second, right?
Right.
The query was in minute. So 0 to 59 minute would be that, like the interval would be an hour.
So we'll go to that, but yeah, for now, just understand that 0 to 59 means 0 to 60. Let me check. 0 to 60 means 1 minute basically.
Regardless of the granularity, the time is always in seconds.
Yeah.
That's how I read the question.
Yeah, you are storing this only in seconds.
Not just storing, even the start time, end time in the get tweet count per frequency function is also time, which is essentially in seconds. If you look at that, right, in the brackets, it says start time in seconds, end time in seconds.
Yeah, we will come to this in next example. So I will tell you why this is why they are mentioning this minute. So now if they ask you minutes here but the value is 0 to 60, then you are not returning 3 actually. You are returning 2 and 1. So you have 2 buckets of 1 minute here, from 0 to 59 and from 60 to 61. See, so 0 to 60, where 60 is not included, you can think it's like 59. There were 2 tweets between that, and from 60 to 61, you will say there is another 1 tweet. So that is the whole point of passing this thing. So you are creating bucket per minute. Think like that. Does that make sense? I will explain on the board, but this is very important, I think. If you don't understand it, we will not be able to derive the actual solution. So this example from 0 to 59, there is 1 minute. And we had 2 tweets in 1 minute time. The second one, the 60 minute, started the beginning of another minute. So that doesn't belong to that particular bucket of minute, if I can say. So you will say, okay, First minute we had 2 tweet, second minute we had 1 tweet. If it was like, we had more tweets at 61, 62, 63, then we will say 3 here. Is that clear? I will wait. If it is not clear, then
Yeah, it's not. I'm trying to digest it, but it
okay.
not clear to me.
Let me draw it then. That will make we can have our own example in that case. So in the first case, we had tweet at 0 and 59, actually 0 and 10. Let's say it is 10 and 59. Was that? But if not, then anyway, suppose. So in this minute 0 to 60, where 60 is not inclusive, we had 3 tweets, for example. Suppose we had tweet at 60, 62, 65, 120. Then we can say that from 60 to, let's make it 120, where 120 is not inclusive, we have another 3 of this. So now if the problem asks, okay, give me the tweet from 0 to 120, then I'm not returning 6. I will check, okay, how many minutes are between 0 to 120. So we'll say, okay, there are 2 such minutes. First is this one. So I will go and check, okay, how many tweets were in this particular minute. So we can go and check, there is 1, there is 1, and there is 1. So, okay, in the first bucket, return these 3. Do we have to fill another bucket? Oh yeah, we have, because there is another minute. So again, how many in this minute? So this guy, these are the valid guys in these. So we'll again have this 3, and we don't have any other bucket to fill. So we'll return these 2. That is the API we have to design.
Yes, it's clear to me.
It clears that out. Okay. So 2 things, they will tell you, okay, the tweet name could be any string. So they were calling it tweet3. So let's call it tweet3. So tweet3 came at 0, tweet3 came at 10, at 59, something like that. So you are first storing that somehow, and then you are returning that in this particular format. So these 2 APIs you have to design. How do we do that? That's the problem. Any problem? If it is not very clear, please ask, because I looked at this problem and a lot of people didn't like this problem for some reason. So maybe it was not very clear, but this is how I have understood it. And if the problem is clear, can anyone suggest any idea what we can do?
So I did it using tree map. So essentially a balanced binary search tree. So
Okay.
every time a tweet came in, so I kept a hash set with the tweet name and then a tree with it.
Mm-hmm.
And every time an entry came in, I just inserted the entry into the tree map. So they were already logically ordered. And whenever I used to get a query for getting the tweets and balances in the the sets, I used to first, based on the frequency type they are requesting, create batches. And then for each batch, I used to query the tree to get the sum. Like if I have, and the tree used to contain the time of the input and how many queries, how many tweets were created at the same time.
Okay, so what Puneet is suggesting is what he did this is suppose tweet 3, right?
Roger, before we go into that, right, I wanted to ask one like
Yeah.
macro question here. So, Puneet, are you trying to store like the number of tweets on a per time basis, like for always, or why are you doing that? Why are you storing everything?
So suppose that you have tweet 3 coming at time 10, and you had tweet 3 again coming at time 10. So I was just trying to store the number of frequency of tweets at the same time also. Like there were 2 simultaneous tweet 3s pushed at time 10.
Got it. So you're not storing all the tweets, but you're only storing the count. But the granularity you're
Yes,
storing the count is at a timestamp level, right?
that's correct.
Which means that if a tweet, if like 20 tweets came at 0, you'll store a value of 0 corresponding to 20. And if like 50 came at 1, then you will store the value 50 corresponding to 1. Correct?
So
Even
if
though
they
the
are,
request is always at a minute level, it's never at a second level. Why are you storing this level of granularity?
because I'm not sure in future, because that minute query, the queries are coming in future. So I don't know whether they will come at minute level, hour level, or day level.
No, the frequencies are given, right?
Right, but there are 3. The lowest level is second.
Is it? I thought it was not. It was like a minute, hour, and day. Let me just read the question again. Maybe I read it wrong.
Just let me also do it.
Yeah, there are 3 actually: minute, hour, and day.
Yeah, it's not seconds.
Right. So I understand. The problem was the minute start time is not known. So they can do a minute, but it can start from like 13th time, right? 13, and then minute frequency is like 13 plus 60. That's your batch.
Exactly. That is a nuance I wanted to call out. So the reason why I asked these questions was that the thing is that so example that Roger has written right now is that if you say that I want 1 minute and you start from 0, then the aggregation is different, and if you start from 1, then the aggregation is different, right? The answer will be 3,1 or 1,3, depending on whether you start from the minute 1 or not, right? So you have to store data at a minute, at a second granularity. That is clear. There is no other way, correct?
Exactly.
Yeah, I
Okay.
think
And now the next question was your choice of data structure. Why did you pick a tree map?
So essentially, I'm trying to have this as a balanced binary tree, so that my every query on the tree is a log of an operation. I don't have to go query everything and then calculate it from the start to end. So I can just query it from the start of batch, get the result, kind of segmentary range query, and then end, and then sum it up. I know it will not be a perfect solution, but yes.
The concern I have here is, what if I have like 1 billion tweets, and those tweets are all like in different, not exactly completely entirely different, but what if they are actually clustered into maybe like 100,000 entries or something like that, and but they are all like multiple. So each tweet, each timestamp will have like maybe 1,000 events or something like that. So you will be spending an n-log and complexity doing the insertion.
Right.
If you use a tree map.
Right.
Okay, so I think you need to think a little harder in terms of the constraints of the problem. Is that you want to store like a straight up map, or you could just store the whole thing in a straight up map. Then the lookup complexity is harder, right? The lookup is essentially, when you're doing the lookup, you will be running through the entire thing.
Exactly.
You
That
can
is
do
what
that
I was
too,
trying
right?
to avoid.
Yeah. So which one is better? Do you want to take the hit at the insert, or do you want to take the hit at the get?
Right. So I assume that the queries were a bit lower than the other, because if that's the case, probably then I have to change the data structure for storage. Then if the amount of the tweets or the batches are smaller, I can probably go it with a simple sorted array, and then query it over there. That will be much faster as if the the tweets are higher as compared to the recordings.
Right. There are only 100,000 operations here. That's the question. Like if I read the questions, right, it's 10,000 operations. That's it, including both record tweet and get tweet. And
but the frequency of each of them
time difference is also not much. So I actually don't see a whole lot of concern in terms of using either approach at this point of time. because even n log n is like, it's a very small operation. So either is fine. Pick the one that actually gives you the most value. So your tree map is fine, or the other one. So I just wanted to let everyone, like, just point everybody's attention to, there are two different ways of solving for it. One is using a tree map, which essentially makes the insertion a little bit more complicated, because you have to do a find every time you do the new tweet thing. But then the retrieval is actually a little easier, because you can actually just go down the tree very quickly and get that. Whereas the other one is where the insertion is actually brain dead simple. You just copy paste, you just put it in a simple hash map. But then the retrieval is more complicated, because you have to iterate through the whole thing. And that's that. And you could probably do something a little bit more cleverer, but that's about it.
So with the tree map, you still need to find the start time and the end time, and then you accumulate the value in between, right?
When you
Correct.
say,
so what you do, what you do is you find the start time, or the value that is just immediately greater than start time in the tree map. Okay. Once you find that, you can always go to tree map's next element. Tree map actually gives you a way of getting to the next element. It's an ordered hash map.
Right. But in the worst case, we could travel the whole tree, right?
No, it won't, right? The finding an element in the tree map is actually log n.
No, I think what he's saying is, if you are querying always from the minimum of tree to the maximum, then you will have to, iterate over the entire tree to get the sum.
Yeah.
Right. So I think what he's saying is making sense, but considering a scenario where, it will always calculate start to end, it will go to a O of n operation.
Correct.
So essentially what he's saying,
that is correct. Yeah. The worst case complexity is actually O of
n square.
Yeah, so fair enough. So both operations, both logic seems to make sense. So can we just go take a look at the tree map approach first, and then maybe do the hash map approach as well quickly?
Sure. So since we are talking about tree map already, and we talked a little bit about it, this is the structure, like a balanced binary search tree kind of stuff. So most of the operations are in O of log time. And so if you have been given a range, like start time and end time, you don't actually have to go at every place. You can just figure out things in logarithmic time, and you only care about that time. You will be able to get the overall result. Once you are able to get the overall result between, for example, somebody asked me between 10 minutes to 50 minutes, and if my granularity was minutes, then suppose I have all these results got from here already, then I have to, just for output, I will try to put it in different buckets, right? There will be like maybe 10 to 50, maybe almost 40 buckets. I will fill one by one, and I will be asking my tree map, hey, now give me the result for the next one. And I know which bucket to pre-fill, right? That's the approach, Puneet, you did, I guess. Puneet?
Yeah.
Yes, right? So that is how we filled it and we returned it. And I already explained it when you guys were talking, is this is how we are storing. We have a map of this key tweet, and it has this tree map as the value, which has these counts, like, at 0th second, we have one such tweet, at 10, we have two such tweets, and at 60, we have these one. So that's how we started to store it. If we don't do it, that okay, for the time being, is there any problem or any questions on that particular approach? We already talked about it. We talked about a little bit about complexity too. And why it is good is because here retrieval is easier, because we are doing, whenever we have to do range query, tree map or any sorted data structure should come to your mind from intuition point of view. Whether that is the best or not, that again depends on, since we are not just retrieving, we are also putting stuff. Depends what we want to optimize. If it is a very read heavy system, then maybe yes. If it is a write heavy thing, then maybe just using a hash map makes more sense, as we were just discussing.
Yeah, one quick thing as well on top of this, right? So
Yeah.
one of the ways you can actually optimize the retrieval as well a little bit by having like the tree itself, right? In addition to containing the value for the node, it can also aggregate everything in its children.
Yeah, here, like
So
you
when
can
you
have here things, right? Don't go
yeah,
below. You are saying that if
correct. So
yeah.
if you are covering everything from the minimum end of the tree to the maximum end of the tree, then the tree node itself, that particular root node itself, should contain the summed value of everything underneath it.
Yeah, but that would that make the insertion a little bit more complex because we need to traverse to the root and aggregate the value. I guess it's fine because it
won't, right?
depends on the
Because
height of the
No,
tree.
it will be actually faster because then you are actually combining two aspects. You are making it a binary tree as well as a segment tree. So you don't need to go down to get the values. It's already
let's talk about
pre-aggregated.
let's confirm the insertion, right? The thing was that since you're doing more work during insertion, the question was, is it making the insertion more complex or is it still the same complexity time wise?
So whenever you do the insertion here, now you have to maintain this also, right? So it will again, like, try to make sure this order is preserved. So it is getting slower for sure.
From time
It won't be
complexity wise, it
slower.
shouldn't be because you anyway
Yeah, it
are
won't be
going
slow.
down. Sorry, go ahead.
The act of actually registering a tweet before we made this change was log n, right? Because you had to go down to the depth, find the right location, increment the value. So it was log n, correct? Now what you have to do is, as you're going down the depth, right? At every step you're incrementing the value. There'll be two values you're storing. One value is value of the node itself and the other value is value of all its children. Okay. So as you're going down the tree, you're just adding the value of children number and then you keep going down. So you're essentially doing 2 times the operation. So which is 2 log n, which is still the same as log n. So this is like essentially storing an order statistic, which keeps the number of tweets for the current timestamp, which is the node value itself. And the second one is essentially for all its children. Now, as you read through it, if you're able to get to, I mean, you will find, if the current node covers the entire child, then you can just read the value of the current one. If not, you just delegate the responsibility to bottom one. So in theory, it's like it's a little bit more if you're looking at very tighter time complexity numbers, like because the constant values and the multipliers are different. But in the bigger terms, it's the same. It's just log n. Does that make sense?
Yes, it does make sense. So yeah, I was thinking in that direction that yes, of course, complexity is theoretically same, but practically a bit higher because it has to do more work. I mean, that is what happens when you apply more indexes in your databases, because yes, it will now start doing more work while writing, because to give you a faster read query, earlier you had just indexed in one column, for example. Now you have 3 more columns you're indexing at. Exactly same thing happens in that case, right?
Right.
Just to give you the faster read, now it will start putting stuff in this particular sorted structure so that it can return things so in the faster time. So exactly same thing applies there, and that's why our read starts to become faster, but the writing takes hit, and that is the reason we don't apply index on all the fields unless we require. Does that make sense?
Yeah. And I think right now it's based on the granularity of the second, right? Suppose if they want to query in the interval of hour and interval of day,
Mhm.
would that the time complexity be the same, or it gonna be, can we improve it?
I mean, time complexity will be the same. The only thing is now you are going to fill more buckets, right? So worst case, we are already thinking about the worst case when someone is asking you from start to end, right? Think your query is okay. Return me everything from the beginning till the end of the
Yeah.
time interval.
I'm asking if we have a way to improve the time complexity when the query, like,
Oh,
hour or day.
I think what you are saying that if we can pre-compute on like, hour level or minute level and just start using that, if the whole bucket is filled. I think Vivek already talked about that approach where he was saying store that here. So that will be an optimization already.
Like
Right,
for
Vivek?
every number, you're actually trying, you're storing there, but you can, but there are like significant amount of concerns with that. So I think um, technically you can create like three maps. One gives you the minute value, one the day, and the one the hour, and you can just insert the same tweet thrice in that. So essentially saying from any starting point looking forward, you can do a bunch of different things with that, but the challenge you will run into is that I think you're now talking about a whole lot of space and a whole lot of time for insert while you are not really benefiting. uh, I mean, the read operation can be simpler later, but it's not really that big of a deal. So I would just, this is like the middle ground where you
Right,
are keeping the order statistic along with the value, so that way the tree is covered. So at a
right.
at a second level, you know what the value looks like, and you're just doing an aggregation for minutes, day, or hour, depending on whatever you want. If the question had been a little more tighter in terms of saying that if I'm asking for minute granularity, I will always ask it based on the start of the minute.
Mhm.
If the it was not start timestamp and end timestamp, but it was actually start unit and end unit. So if they had said that it'll be minute, start minute and end minute will be it'll just be always like, zero aligned for seconds, then you have some opportunity to do a little bit more compression at that point of time. Right now, not really. So I think in the interest of time, let's actually move and do do you want to do the hash map thing? But I think it's the same concept, right?
Yeah.
Except that instead of remap, you're just putting it in a hash. That's it. You're just counting all the elements and that's about it. It should be very straightforward. I looked at a few solutions that people have written and looks like most of them have used the hash map solution.
Oh, I see.
Because tree map is complicated to implement, right? I mean, you have to think about it. Either you have to use inbuilt functions or not. Hash is like easily available, and you can just go ahead and implement it pretty straightforward. If you look at any example, you can click on the code link, which is in the table of the rankings, and you can see people have taken about 10 to 20 minutes typically to solve, and most of them have used a tree map based solution, not tree map, a hash based solution.
I see. I see. Okay.
I had to in fact learn tree map to solve this because I usually code in C# or Java, and they don't have any inbuilt, the binary or AVL trees.
So Java had tree map, right? So it gives a lot of things there. By the way, like since we were talking about a hash map and we always think about the complexity is O of one, I will take 2 minutes to clarify one thing. So, hash collisions, if there are too many calls, it may turn it into O of n, right? Some of you may already know that. So I won't go into that too much because of like, internally it will start having this kind of linked list where it has to start searching. And then if your hash function is not good enough, or if you have too many collisions, this will not be a very good time complexity. So what Java's hash map does, it will give you O1 up to certain time. And after some time, if the size is too big, it just converts it to like, sorted structure. So it will start giving you O of log. This is like internals of hash map. I just learned, so I thought I will tell you. So in theory, we will say O of one, but they change the implementation after some time, like, after certain threshold, that, hey, just convert it to log implementation, because they know that it will give you a better result. I may share that screen, like that link maybe later if I remember, but I did read about it a couple of years ago, 2 years back, I guess.
Okay.
Okay.
Thanks. Oh, can we quickly go over the second approach?
The hash map?
Yes.
Okay, so let's do that. So here we have the same thing. Here we have hash map, and so put anything is very fast here, right? Write is fast here, because you know that this is giving you off one time to write for sure, right? In theory. The problem is when you have to return something from start to end, like, suppose your time starts at 0 and ends at 40,000, for example. Let's call it minute or whatever. And the granularity is 40,000, for example. So you have these many buckets. Now, how would you fill that? You will go one by one, right? You will look into, okay, here, let me zoom it a little bit. You have this, oh, actually, I already have it here, this side. So here you will say, okay, 0 falls in first bucket, okay. 10 falls in, you will also look for 1 because you don't know what you have. So you will go check on the first second, second, third second, and finally you will find something on 10th. So you will go through each possible values for all the queries, right? So you are scanning this way. For each read query. In tree map, that was giving you already, like, values between some start time and end time. It knows about that because that is how it was implemented because of the sorted nature. And the question, if it was like, from T1 to T2, then you will go from here. Like suppose this was T1, you will start from here, you go down, start accumulating your result, filling your bucket, and then just return the result.
This is the hash table, right?
This is the hash table. You can think it as a hash map.
Okay, yeah. It's not order. So I still need to go first, the second by second and look it up.
Yes, it will go second by second.
Good. Okay, I see.
All right.
Okay.
I think we are done with this. I guess.
Yes.
Okay. Let's go to the last problem for the day. Okay. How do I